Hello everyone, welcome back to CHM 577 in organic chemistry. So let's continue with the hybridization and valence bond theory. So for this part, we are going to, or I will explain to you what is a valence bond theory and orbital hybridization. So what is hybridization and what is a hybrid? Hybridization is a mixing of two or more atomic orbitals to form a new set of hybrid orbitals, while for the hybrid is the name for the new compound, or the hybridization is a process, while for the hybrid is the new compound. Alright, so there is two things that you need to aware in this hybridization. The first one is the number of hybrid orbitals must obtain equals the number of atomic orbitals mixed, and the second one, the type of hybrid orbitals obtained varies with the types of atomic orbitals mixed. So we have 5 types of hybrid orbitals, okay? So the first one is the sp, alright? So this is where we have a linear, okay, geometry, and then we have a sp2, so this is a trigonal planar, alright? And we have sp3 that represent the tetrahedral geometry, and also sp3d, alright, this is the trigonal bipyramidal, while for the last one is sp3d2 that represent the octahedral geometry. And how do I predict the hybridization of the central atom? So in order for us to predict the hybridization of a certain compound or central atom, okay, so we need to count the number of lone pairs and the number of atoms bonded to the central atom. So it's actually the number of lone pairs plus with the number of bonded atoms. Okay, if you have this equal to 2, it will give you the hybridization of sp, for example beryllium chloride. Okay, if you have the total number of these is equal to 3, you're gonna have the sp2, which is represent you the trigonal planar shape or trigonal planar geometry, and the example is boron trifluoride. And then if the total number of lone pair and also bonded atoms is equal to 4, you will be getting the sp3 hybridization that represent you the tetrahedral geometry. And for example, we have methane, ammonia, and also water. And if this 2 is equal to 5, you're going to get sp3d, the hybridization of sp3d, and for example phosphorus pentachloride. And last but not least is if the total number of lone pairs plus the bonded atom is equal to 6, you will be getting the hybridization of sp3d2, and the example is sulfur hexafluoride. Okay, so this is the end for this part, and for the next part I'll show you on how to predict or how to actually draw the orbital diagrams for the hybridization from sp until sp3d2. So I'll see you in the next part. Bye.